All right. Good morning. Couple of housekeeping items. First, okay, ignore the hidden things. They're hidden for a reason. But I did post this intro to mom quiz, but I think it was unavailable to students until yesterday. That's my bad. And if you didn't notice, then that's fine. So it was supposed to be due on Friday this week. I made it Sunday just so you have a little bit more time. And on that note, I want to just give you the inside scoop, because what happens is I like to put something in the calendar, and often I'll change due dates, you know, if we're running behind or whatever, then I'll give you more time. And so sometimes what happens is I don't update the calendar because I forget. I tried to remember, okay, so don't go by this calendar. It's always going to be earlier than it actually is. But if I had said, oh, I'm going to move that to Sunday, like I just did, right, and it's still showing up as Friday, this doesn't mean anything. I've just manually put it in the calendar. And so don't go by that. And I only bring this up because often I'll get frantic texts saying, I thought you were going to change the due date. I did. So how you know what the true due date is if you open it, it'll say when it's due. Okay, that's the true due date. Okay. The other one, I'm just trying to kind of help you out, but I forget to update it sometimes. Okay, so now you know what that looks like. Okay. What was the other thing I was gonna say here? I feel like it was those two things. Let me just scroll down to see. Oh, three things. On Monday, I had posted, or for Monday, we were talking about, I just posted the PDF of the textbook, okay? And then I went and I looked, and I guess there's a slightly newer version. So instead of 2.2, there's 2.3. So I figured we should all just use that instead. So if you did do a download, I'm sure nothing's changed in chapter 1. So it's totally fine. I didn't notice any changes, but if you just go in, hey, why does it say 4 through 8? That is confusing. Don't do that. I'll do this. No, when did I do it? Yeah, I think so. Yeah. You can tell by as long as the front page says edition 2.3, then we're all on the same page. But okay, let's see here. But that's not what I wanted to do. I wanted to do a new. Oh, and of course they changed everything on me. Oh yeah, the internet in the B building is not good. Yeah, so don't worry about that. But I'll just do this. And you know what? I'll penalize myself in red, chapters 1 through 8. That's my mistake. Oops. Oopsie poopsie. I don't know why I did that. Going too fast. All right. So let's see here. It should be edition 2.3, right? And see title page. Just make sure that we're in the same edition. Like I said, I really don't think that they made very many. It's probably in the later chapters that they made some changes. Okay. All right. That's all the housekeeping. Usually I do some review. We're starting, so there's no review. Nothing to it but to do it. Any questions before we do? All right. So chapter 1. Oh, and I will say, trying to do chapter 1 in this week, turns out it's very ambitious. It's like, oh, functions, oh, whatever. But then when I look at this, I'm like, okay, yeah, that's quite a bit of material. So I'll make adjustments and whatever, but we'll start at the top and work our way through. But chapter 1 is on functions. So you know what? I'm going to steal their fancy. I hope it's not too annoying for you. Did I already bellyache about my carpal tunnel? Probably. I'm trying to not write so much, but it's not really my style. So I'm trying to save my wrist a little bit, but we'll see how it goes. All right. I did post more housekeeping. Oh my gosh. Clam it, Emily. I did post this PowerPoint of the examples, just so you don't have to write them out necessarily if you're typing or whatever. But they're just the examples. Oh, I don't want to do that. No. Just so you have them, right? I'll give you time to write them out. They're not that long or anything, but just so you have them. Yeah. And I kept it as a PowerPoint. I did steal them from the author, but I thought that way you can copy and paste easily and that kind of stuff. Okay, functions. What's a function? Well, these, and yeah, I did do a math degree, blah, blah, blah. But I remember, especially in high school, functions, I knew that I was supposed to know what they were and I was supposed to understand, and I could do problems and stuff, but for some reason, I couldn't kind of wrap my head around this f of x until I said, okay, well, I guess f of x can just be replaced by y, right? And so we've seen things like, or you might remember y equals mx plus b. That's a pretty common function, right? That's the equation of a line. So here, this is the equation of a line. And we'll talk more about it, but it's good to remember. So equation of a line with slope m and y-intercept b. Okay. We'll come back to that, but just that's a common function that we've all seen and know and love. And so what we can do is f of x can be, oh, hey, what a mess, mx plus b. And so really all it's saying is the function f takes some input x and returns f of x, which is the output, right? So x is the input, and so here, that's the variable, the input variable. Oops. The input variable is the x, and then I'll use a different color. The output variable is f of x, right? Some function of x. So much for me not writing, I guess. A function of x. I told you, it's not my style. I like to write it. And I post these notes after class, right? So you'll have them in case, you know, in case I'm going too fast. You'll let me know if I'm going too fast though, right? Yeah. Okay. Yeah. Hands up. Well, there's nothing I can do.
Where are we right now on our? Here.
We're in 1.1, which I am gonna sneak in there. How about that? Just introducing functions. Okay, I'll do this. Bink. I know, so sneaky. I can do rascally stuff like that, but I know it's rude. If you've written out your notes, and then all of a sudden I go bumping things around, it's rude. I know, I try not to, but that actually looks pretty good. Chapter 1 functions, section 1.1. Should have done that from the beginning. All right, so we're obviously going to be working with a lot of functions. We need to be comfortable with functions. And so for me, the key with kind of getting functions, I guess, was just when I see f of x, it was helpful to me to just replace it with a y, if not just mentally replace it with a y, right? Because then if you have an xy axis, then all of a sudden you put in an x and you get a y, right? And so then that's what kind of helped me understand this idea of functions and maybe even function notation, which we'll talk about. Okay. So here you can just, even if it's just in your mind, right? Y takes some x, and then we get some y, right? All right, so a function, what the definition of a function, this one's a little bit big, but a function is a rule, obviously, for a relationship between an input, so an x value typically, and then they've got multiple terms, but let's just talk about input, output, so you can ignore that independent, dependent stuff. So an input quantity and an output quantity in which, and I'm going to highlight this here, in which each input value uniquely determines one output value. Okay, and so that's the thing that we're going to need to keep in mind for what is a function, right? If I give it an input, I can only get one possible output. Okay, so each input, so what this is to say is that any input can only yield one and uniquely determines, right? So one possible output. So do you mean like this?
Yeah.
So then each value of x is going to give a unique value of y. However, these two, well, imagine they're symmetric, right? Like this. Those are two different inputs. So we're allowed to have two inputs giving the same y. Okay, but the key is that it's only the one way. So if I give you an x, it can only give you one possible value of y. Okay. I'll erase this because we're not doing graphs yet. But, yeah. So that's what we want to keep in mind. Okay, so if I have, usually, kick it old school, usually we have some visual like this, I have 3 possible values of x, and f of x, we can have only 2 possible values of f of x. That's fine, right? Because if I give it x is blue, well, blue might give me a result of, let's call these 1 and 2, right? If I give it an input of pink, well, that might also go to 1, right? But each input gives me 1 possible output, right? So what I'm saying is we can't have something like this, right? That makes it not a function, right? So here, this would be not a function anymore. We can still deal with that, but it's not a function anymore. That's the key. Okay. And maybe orange, it's doing its own thing over here, going to 2. Right? But it's that unique output. That's the key. Grabbing that first example, oops. So big. Guess it's good. Gonna bring it in. We're talking about just functions, and like any good textbook, if you need more examples, there's a lot more examples in the textbook, but we obviously don't have time to go through each of them, right? But just make a note to yourself that go back and review those if it's not quite clicking yet. Okay. So if we have a student ID number is quantity 1 and quantity 2 is the student's 11 a.m. class, right? So what class are they in at 11 a.m.? We want to know, is ID number a function of the 11 a.m. class? I would say no, but, and this one's kind of tricky, okay? Why no? So here, totally. So the ID number, is ID number a function? Oops. Of the 11 a.m. class. I shouldn't write f of x quite yet. I'm going to say, is ID the output of an 11 a.m. class, where the 11 a.m. class is the input, right? If I tell you, oh, at 11 o'clock, I have wet math, you wish. At 8 a.m. we have a wet class, right? Well, there are business classes, there are other things. In fact, there are what, 20 different ID numbers in this room, right? So knowing that you're in this 11 a.m. class, it doesn't give me one unique student number, unless it's a special case where there's only one student registered. Doesn't happen. Although I was in a class once where I was a student, and there was only 2 of us, but the prof still talked to the entire room, but we're sitting together in the front. Okay, so because 11 a.m. class, right, produces many different ID numbers, no, since there is more than one ID in each class. How about that? If I input your student number, That'll tell me where you are in your 11 a.m. class. Let's assume you have an 8 a.m. Right, and so for that reason, right, the output, this is the input, it produces a unique result. You can't be registered in more than one class at 11 a.m. on a given day. Okay. A student can only be registered in one class at 11 a.m. on a given day. Okay. I guess I should say yes. Didn't answer the question. Huh? So I don't know, maybe I'm just weird, but these are hard for me to wrap my head around, but I can still do the math, right? So don't sweat it if reading these kind of wordy things, it's hard. It's hard. All right. So I know what you're thinking. What if I want to have each output is unique to an input, so it goes both ways? Well, that's a special case. That's called a one-to-one function. So we can have that. It's not always the case, but it is a special case. An apple for me. Yeah. So the special case of a one-to-one function is when each input corresponds to exactly one output, and every output corresponds to exactly one input. So you've got this clear pathway, right? None of this fun stuff, right? Where blue goes to 1 and pink goes to 1, right? You just have one input goes to a unique output, right? And a unique output goes to a unique input. So what would it look like? Might look something like, oops, I wanted blue. What would have to be the case then? 1, 2, 3. I would have to have 3 outputs, right? 1-to-1 means that each one can only map to one output, and it can't be the same anymore. And the other way around, right? So that's a special case of a one-to-one function.
That formula is just f of x equals x then?
So it would look like,
That one example, percentage of decimal.
so it would look like potentially a straight line instead, whereas not a one-to-one function is that quadratic, right? Because then I can give a value of x equal to 2 and a value of x equal to -2, and I would still get in x squared, I would still get an output of 4 either way. That's not one-to-one.
That's just a 45-degree slope.
Any straight line. Because here, it doesn't matter what the slope is. Let's do this. Here, I'll do y equals. I didn't mean to keep these on here, but maybe I'll just keep them for good measure, right? But what I can do is any value of x, it doesn't matter, produces a unique value of y in this case. And we're gonna see more one-to-one functions versus not one-to-one functions. We'll have some tricks up our sleeves, but that's visually what it would look like. Okay. They've got this kind of fun, I'll just grab this part, breakdown of function notation, which is way better than what I usually do. I usually just say, I'll give you what I usually say. So function notation, I usually just say, okay, you've got function notation is something like this. F of x equals mx plus b, for example. Okay. All I usually say is, well, this, you just read it as f of x. That's not very descriptive compared to what they did here, so I'm going to steal that. Anytime that you have brackets, though, right, and context will tell you if you're multiplying or not, right? And so sometimes brackets mean multiplication, but if you have the name of a function out front, then how you're going to read these brackets is of, right? And then of whatever's inside. Okay. And so we can start off, this is way more thorough. If we're talking about height as a function of age, you can see how you don't want to be writing that out all the time, right? And so that's how notation is evolves, right? And so we could say, okay, how about I just let h represent this height, okay? And how about I let a represent the age, okay? Height is a function of age is where we're starting. Okay. Let's just pick a name for the function. Usually we use f, right? Unless there's a clear name that we should be using, but just generically, let's use f, okay? So then what we can do is we can replace this word function and say h is f of a, right? Replacing height with h and a with age with a. Or replace the is with an equal sign, that's still true. And then the of with those brackets like we were talking about, right? And then so h is the function of a. That's so height is a function of age. That is still what it says. But then what we can say is, well, okay, I've got two names here. What if I just name the function h instead of f? And then that's how we arrive at h of a. Height is a function of age. Okay. And so that's what we're working with. Okay. And we'll do a lot of function notation. I'll snag this just for completeness. These authors, they've done a really good job of highlighting the important stuff. And so if you're reading the textbook, just pay special attention to these. I will be snagging all of these, right? They are worth thinking about, talking about. And so just, they're helpful. Okay. Just little summaries. Okay, but function notation, so output is a function of the input generally. That's what how it reads. How about, oops. Let's think here. If f is a function where we give it some holiday and it returns the month that that holiday is in, right? We can use functions for words. So here, this is the input and the month that it's in is the output, which is f of x in general, right? Then what if we evaluate f of Halloween? It's coming up. Are you ready? What are some, well, okay, Barbie costumes, obviously. I think there's going to be a lot of Barbies and Kens out there. F of Halloween.
October.
What if we have to solve f of x equals November? What are we solving for? We have to solve for the input that yields the output November. We've got a few, right? Remembrance Day. Hey, I thought Thanksgiving was in November. It's not.
American Thanksgiving.
Yeah, I'm American at heart. American. No, I'm not. I'm Swedish, so I'm pretty far from American. But yeah. Is there another one in November?
I don't think so.
No, American Thanksgiving. I'd mark it wrong. So the input would have to be Remembrance Day. Remembrance Day. I'll just write it all weird because I can't spell it. And did I say it right? My mom says it wrong and now it's rubbed off on me. And I can't remember how she says it. It's probably for the best. Remembrance Day. Okay. Notice the difference here and here. Okay. When we use the term evaluate, we have some input, so we're given some input and we have to find and evaluate the output, right? So here, evaluate means given, given the input, so X, right? Find the output, f of x. Right? Whereas when I say solve f of x is equal to November, then I'm asking you to solve for the input, right? Solve for x. Given some output. Given the output f of x. Okay. So that's the difference between those two things. That's not something that you have to memorize necessarily because it'll be obvious, right? If I have given you the X, right, you knew that, okay, now I have to find October or give it October, right? And then when I said solve f of x is equal to November, you knew, okay, well, I have November, so she probably wants the month that, or the holiday that gives me November, right? So you know those two terms even without knowing those. Yeah. I wanna It's pretty cute. How about another example? If we have some function c of p, right, is how you would read that, right? It gives the cost, presumably c, right, of grooming a poodle weighing p pounds, okay? And so p is the input and the cost would be the output, right? I want to interpret c of 20 equals 30. Okay? So what's this saying? Well, the cost of grooming a poodle that weighs 20 pounds is $30, right? So here, the cost of grooming a poodle that weighs 20 pounds is $30. All right. Not sure why it would go by weight, but it doesn't matter. I'm not here to question it. I just, it's kind of weird. All right. Now, is this when I had something? I'll nab this. We've already talked about it, so you don't have to copy all this out if you're writing frantically. Don't worry about that. But I will have it here in the notes because it's just talking about the difference, between solving and evaluating functions, right? So like we said, when we work with functions, there are two typical things that we do: evaluate and solve. Oops. Okay. Like we said, evaluating is we know some input and we use that function to determine the output, right? Whereas solving is when you are given the output and you have to work backwards to find the input. Typically solving for X kind of, in my mind, it's working backwards, right? You have to unravel the function to solve for X, is a little bit more difficult, right, than if just evaluating, okay? But mostly because solving a function, it could produce more than one solution, right? Remember, we could have two outputs going to one input, right? By the definition of a function, it's just the one-to-ones that are easy, right? But if you have x squared, for example, y equals x squared. Let's do that. So for example, f of x equals x squared. I'll use my mental trick. I just replace f of x with y. Makes it easier for me, at least, right? And now what I want to do is I want to solve for x. Right, if I have to solve this. So then I get I always want to have what I'm solving for on the left-hand side. So I do this revolving door thing, which I know is confusing. So I'm going to try to not do that. But if I want to solve for x, I have to get rid of that square, right? And so I have to take the square root of both sides. So I'm going to take the square root of y as the square root of x squared, which is how I'm going to cancel these guys. We'll talk about why when we get to exponents, but that's just a fact. How about, but the problem is when I take the square root, I actually need to have the plus minus out front, okay? Because I can put in negative square root of y, and if I square that, right? Then I get positive value, right? Where am I going with this? Visually, let's do that. This is x squared, right? Y equals x squared. Here and here. X can be the negative square root of y, or x can be the positive square root of y. You get the same value of y. But here's my revolving door that I will start to do kind of before this step is I like to have x is the plus minus square root of y. Just put whatever I'm solving for on the left-hand side. I'm usually pretty picky about stacking my equal signs. I didn't do a very good job here. So just look away for a sec. How about that? That's better. Picky things, right? But stacking your equal signs, that's just good math practice, okay? Unless I'm at the very end of a page and towards the end of a problem, then I'll do my equal signs running this way. If it's like the last answer or whatever. But generally when you're showing your work, you want to stack your equal signs. It just makes it easier to read. And that's your job, right? When you're showing your work, you're showing me how you thought about this problem. And then that's going to help me figure out where things are happening. Usually in the case where things go wrong, right? So, all right. And then like I said, I like to have what I'm solving for on the left-hand side. But the equal sign is nice. You can just switch around. Okay. All right. So I've already kind of sneak previewed the graphs for functions, right? All functions, we can graph them. Some are easy, some are hard, right? But we can also use tables for functions, right? To give us functions. And so if I go back here, it's where I had to skip ahead a little bit. But we can use tables to represent functions. I'll just snag that little breakup point here. Here. Okay. Depending on the scenario, right? A table might just represent some key data points, right? Input, output, that kind of thing, but they're pretty limited. And so, for example, if we have the input is the month, right? And the output is the number of days in that month, right? Then if I give it 1, right, it has in a number. Oh, and it's not a leap year. There's all these conditions, right? First month is the input, the output, 31 days. Second month is the input, the output is 28 days, et cetera, right? So you can map this function out, right, in a table. You already know all the outputs, so why? But it's just nice to work backwards, I think. Yeah. What if we have kind of a different function? So if we have some function q, which is g of n. Now we don't know what any of these are anymore, right? And so we rely on the table to tell us what, okay, if I give it this input, what's my output, right? There's no function or formula that we can use. So we're just relying on this table, okay? So g is the name of the function, n is the input, and q is the output. let's do this. Snag this here. What if I ask, what is G of 4? Just kind of translating here. This means that n is equal to 4, right? I give it the input 4, so then I go here and I say, okay, n is 4, which gives me an output of 6. So that's just how you're gonna read these tables if you are given just tables as functions. Pretty rare, right? We outgrow that pretty quickly, but I do think it's quite fun, right? So let's see the example. Can I snag this whole thing? Whee. Bless you. I'll just zoom in here. So remembering the key thing about a function, right? What's the definition of a function? One input provides a unique output, right? So just keeping that in mind, then does each table represent y as a function of x? Okay, so here, what we're looking for is it's asking, does an input map to a unique output? Yeah. Figured I better double check myself. All right. Okay, so I've got an input of 2 gives me an output of 4. That's fine. 4 going to 7, okay, and then 6 going to 4. That's all good. 2 goes to, so this one's fine. Let's do a little. Whee. We're happy. All right. This is fine. They're allowed to have the same output, but the input can only go to one thing, as opposed to, I guess, spoiler alert, right? 2 going to 7, oops, 4 going to 5 and 4 going to 4, no can do, right? It's not going to, so 4 gives me 2 possible outputs, right? Visually, that would be like this, right? If we're going back to that kind of visual that we were using, right? And so that makes it not a function. It can still be a relationship, but it's not a function, okay? 2 goes to 7, 4 goes to 5, and 6 goes to 4. I'm fine with that. All right. Which one of these is 1-to-1? Next. So it's a function and it's 1-to-1. Step number 1, it has to be a function. Step number 2, is it 1-to-1?
So how do we know it's 1-to-1?
Because each input is unique and each output is unique. As opposed to here, 2 maps to 4, that's fine, and 6 maps to 4, but there's not unique outputs. Nice. All right. So if it's a function, evaluate f of 2. So here we go. F of 2 for this one is, I give it a 2, it gives me a 4. How about f of x is equal to 4? Now I'm solving this thing, right? So now I have an output of 4, which happens here and here. So now I have two possible inputs that give me an output of 4, and that's okay, that's allowed. X is 2 or 6. I'm using the word or because it can't be both at the same time, right? But either one of those is going to give me an output of 4. Should have used, you know what? I'm gonna do it. I'm gonna switcheroo this to be a different color green. And I'll change this to dark green too. Just to keep track, kind of doing things all over the place. How about this one? The middle one is not a function, so we can't do anything with it, right? And so f of 2 is 7. Hopefully everyone's good with that. I didn't give you a chance. There. Now, dark green. We want to solve f of x is equal to 4, which means that the input x must be 6. And because it's 1-to-1, we only get 1 x. Nice. Okay. Graphs. All right. So we are going to start talking about graphs. And one thing that's really helpful about graphs is to decide if something is a function, we can use the vertical line test. Now, I'm going to grab both the vertical and the horizontal line tests because they're right next to each other. And we'll talk about them. So given a graph, maybe I should write that out first. So given a graph, we can determine if it represents a function using the vertical line test. Okay. So the vertical line test says that if you have a graph, any graph, if you can draw a vertical line, and I always have to remind myself that horizontal is this way because that's the way the horizon is. I don't know. Sometimes I fear I have a memory problem. I have a really great memory for a lot of things, but things like nickels and dimes, I do not know which one's which. And maybe the problem is I don't care. Horizontal, vertical, there, I did it. Horizontal, vertical, that kind of stuff. I don't know. So maybe I say those things to clue me in more than you guys. But anyways, so the vertical line test looks like this. So you have a vertical line, and given some graph, what you're going to do is you're just going to draw an imaginary vertical line all along the graph. And if it only intersects the graph at one point, right, then you have a function, okay? And so might look something like this. Really hoping they've got a graph for me to steal. Okay, let's do this. And you know what? Copy, crop top. I know. I didn't want to have the horizontal line test right away. Too much, but I will put it down here somewhere. But where did it? I'll just delete this. Still there. Okay, so the vertical line test here, right? We're gonna draw vertical lines all along here and things are tight, but right, because this graph keeps moving, right? It's tiny, tiny increments of X, but at any vertical line, I'm only crossing this graph once, right? So it is a function, right? I'll just draw a couple of lines like this. I'm gonna steal the grid, right? And so it is a function because it passes the vertical line test. This line, same deal. This one's easier to draw, right? Chop it up. There's only one point. I'll draw on this one, right? Each vertical line only has one point on the graph. So again, what does that mean? I'm happy. It is a function. Is that better or worse than the smiley face? Circles exist. No doubt about that, right? However, they are not functions. So that's what I was saying about, okay, we're going to be able to deal with things that are not functions. That's fine, right? R squared is x squared plus y squared, that kind of thing, right? So we can still work with circles, etc. They're just not as fun because I'm going to go ahead and say because they're not functions. Just a little bit trickier, right? But here passes through here and here, so it's not a function. Oof. Whenever I write function, I used to type up my notes. I've gone through like different teaching style phases. And so, but as a rule, if there's a typo in my notes, I would just read the typo. But then one time, without thinking, I had written function without the N, but I still said it in class. And it's very embarrassing. So now whenever I write function, think of that terrible moment. It was funny though, but now in hindsight. It was funny at the time too, but anyways. So circle is not a function. Okay. Let's see here. Then what do we think the horizontal line test might do? Oops, while I crop this out. The horizontal line test does the same, so we do the same thing, but what we're doing is we're seeing if there are unique outputs, right? And so now we're seeing if it's a one-to-one function. So if a function, or sorry, if a graph passes the horizontal line test, it is a one-to-one function. So snagging, I'll go grab this clean one instead. Okay. Just visually, if we're using the horizontal line test, okay, now I'm drawing the lines horizontally, and right away I'm crossing at 3 points in a lot of this graph, right? And so not a one-to-one function, because let's see here, let's do this, right? And you only have to find one instance where it's not true to render the whole thing not true, right? And so here, this is not one-to-one because it crosses at 3 different, pardon?
I just have one question for that.
Yeah.
When you're doing something like breakpoint coordination, do you know how that formula would work? Because that one point is not one-to-one, but then once you get to the breakpoint, it is one-to-one?
Does it? I don't know, but does it look something like this?
Yeah, the first part will be curving and then coming back down, and then once you get to the breakpoint, it'll be like a 45-degree angle up. Yeah. But by your horizontal test, it would not be a one-to-one.
It's not a one-to-one function, but it still passes the vertical, so it's still a function, but it's not one-to-one.
But once you get to that one point, every 1 point of forming add is 1 point of free pouring, so it's always like perfect.
So it's just a straight line.
Yeah, I'm just curious how you say that in like an equation to satisfy like an answer to it.
This, to me, looks like a piecewise function, right? Where we would use one function to describe this, and then we would say, okay, once you hit this value of x, then it behaves like a straight line. And we're going to talk about piecewise functions. So I'll remove this because I don't really know what I'm talking about here. The math is fine, but the break thing, I don't know. But if it looks like that, then I would say it's a piecewise function, which is fine. You're just breaking things up. The middle one, right? It was a function. Well, I guess I didn't use that gatekeeper in the first one, right? But we did decide it was a function because in order to be one-to-one, it first has to be a function, right? So that means we don't need to do that one because it's not a function, right? So the only one that's left here is this little guy, and looks good to me. And so it is one-to-one because it passes the horizontal line test. Passes the horizontal line test. Eee, sneak that on. I don't know, you guys probably can't see this, but there's a page break here. So when I generate the PDF, instead of having it just one word on the next page, I try to, but then it looks weird while we're here, but then it'll look normal later. It'll still look tight, but it's all on the same page at least. I'm a slave to these page breaks. They're subtle, but they're there. All right, how are we doing? Nice. All right. What's next? Let's see here. Hey, I should have assumed that they had a nice example for completeness. I'll just throw it in here instead of snagging from the textbook, right? What I'm gonna do is I'm just gonna first look at these, right? Which of these are functions? I already gave you a clue with my chopping hand, right? To determine if it's a function, we use the vertical line test, right? Chop, 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 chop. And so this one looks good. Ding, 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 ding. Eee. Moving across looks bad. Oh, I'll be consistent. Not a function. Next one looks good. Uh-oh. Only a few spots, but it only takes one bad seed to make it not a function. Nice. So one thing that I'll show you is just if you haven't used Desmos before, I brought it up last time, but it's just a free app, and it's just nice to be able to check your work, right? You won't have it on a test, but for kind of homework questions and just general understanding, it's nice to be able to grab something and just visually confirm that it's a function, for example, right? I think there was another back example here. Fine. We can use graphs to evaluate and solve problems, right, for functions. First off, this is a function, right? Passes the vertical line test, so that's all good. And what we want to do is, first thing we want to do is evaluate f of 1, which means that I'm going to give it an input of 1, so x equals 1, and I want to know what the output is. Well, the output, we can only do an approximation here, right? Because somewhere here, bless you, right? And so f of 1 is roughly sounds like everyone kind of agrees. 2.8 looks reasonable, right? If you had a graph in Desmos, you could click it and see what it actually is. But whenever you're kind of guesstimating, right, just make sure you use these squiggly equals, and then you're safe. Right? All right, then, so that's that one. We wanted to solve where f of x is equal to 1. So now we're given the output of 1. So I know that, okay, here's the output of 1. And now I want to map it back down. And I'm going to say that x would have to be 0, right? Because this is the 0, 0. So if f of x is equal to 1, x, you know what? I'm not that bold. approximately 0. Feeling good, but I can't see exactly. It's fine if you, okay, my squiggly equals are sloppy. Okay. Roughly 0. Okay. Is there a note I wanted to pull in? Yeah. Let's see here. Did I miss something? Oh my gosh. Thank you. There, I'm done. What happened here? Oops, thank you. Keeping me honest. X is roughly -2 and X is roughly -4. I can only handle one-to-one functions. Sleep at the wheel here. All right. Too busy trying to remember if there was something from the textbook that I wanted to introduce before we do. Let me just look. Need a little nudge sometimes. Okay. Formulas as functions. We'll introduce this, but this is probably where we're going to spend the most time, and where you have spent the most time in the past is just you have some formula and you treat it as a function. And so here, let's do, unless I forgot something else. So here we have this formula, which is actually a function in disguise, I guess, because what have we done? So usually if you have a formula sheet, then it would just say P is equal to 3k squared plus 1, right? But what we can say is we could replace that P with some function G of K, right? Where K is the value, the input value that we would change, right? And so G is the name of the function, K is the input, and P or G of K, which are the same, right, by the equal sign, are the output. Okay. So given this formula / function, they're the same, we're going to evaluate G of -2. I'll do it like this. So a G of -2 I need just a little bit more room here. Just a smidge. Because what I usually like to do is just write out the general formula that I'm about to use. It's a pretty standard. That's what you should do. Okay. Tell me what formula you're about to use. And then if you plug in a weird number or whatever, then I can follow that. Well, you meant to do this, right? And so typos are fine. But if you don't tell me what you're about to do, right, then I can't give you marks, which is the name of the game, I think, usually. So G of -2, well, that just says, okay, the input is -2, so plug in K is -2 and figure out what the output is, which you can either call G of K or P. Now, order of operations says that bedmass, right? Brackets, exponents, division, multiplication, they're on the same playing field. You do them in the order that they appear. Addition, subtraction, same thing. They're on the same playing field, right? So you do them in the order that they appear. And so bedmass. I've also seen PEMDAS, but I feel like that's an American way, and we say bedmass and they say PEMDAS, but it's parentheses. PEMDAS or bedmass.
Yeah, down in Washington, we learned, please excuse my dear Aunt Sally.
Yeah, I heard my stuff. Like, what?
Well, when I was growing up, it was bedmass, brackets instead of parentheses. It's just what is it? Is it an acronym? No, it's what's the term? Is it an acronym for the order of operations? It's just like a memory helper. But what do we do first? Brackets. Well, there's nothing to simplify inside the brackets, so then I'm going to do the exponents. And because we don't know each other very well, I'm going to write out every step. You can kind of, you don't have to write out every step when you're showing your work. Every step that you show me, though, I'm happy. But sometimes it's a little bit excessive. So -2 squared is going to be 4. So 3 times 4, I'm going to use the bracket for multiplication. If you are in the habit of using X's for your multiplication, you're going to need to shake that real quick, right? I don't want to see something like 3 times 4, because is that 3x4? Right? We're going to be working with X's, and so you don't want to do that. Right? I prefer to use brackets. You can even use the dot, but sometimes it slips down and makes it look like a decimal, and that makes a mess as well. So I like brackets for multiplication. All right, brackets, exponents, division, there's none. Multiplication, there is. 3 times 4, it's usually 12, yeah? I am confirming when I say stuff like that. I really am. And then addition, subtraction, well, I've got 1. So G of -2 gives me 13. And I'm out of time, so we'll use G of K is equal to 25 for a review on Friday. If you have any questions, let me know. Otherwise, see you later. I'll stop this recording here.
So we're doing it here at 5:20.